New South Wales residents are advised to keep a watchful eye out for the latest border jumpers, cane toads, hitchhiking their way into the state through freight.
Australia has spent many years fighting an animal that poisons snakes, kills crocodiles, and spreads almost everywhere it goes. Cane toads looked impossible to stop. Their toxic skin turned hunters into victims, and almost nothing people tried seemed to work. Then scientists saw something shocking near muddy ponds. Tiny ants, about the size of grains of rice, were attacking baby cane toads and tearing them apart within seconds. How could such small insects survive poison strong enough to kill much bigger animals? Join us in this video as we reveal the details. A tiny ant in Australia is taking down cane toads. For many years, cane toads have been seen as one of the biggest animal problems in Australia. These animals are not small, harmless frogs. They are toxic animals that spread fast, survive in hard places, and hurt native wildlife. Many people believed almost nothing in nature could stop them. Then researchers noticed something strange happening near ponds and muddy water edges. Tiny meat ants were attacking young cane toads. At first, this looked impossible. The ants were very small. The baby toads already carried poison. Most animals stay away from cane toads because of this poison. But the ants did not stay away. They moved toward them. Researchers watched groups of ants rush from the ground and surround young toads that had just left the water. These baby toads were very small, about the size of a fingernail. Even at this stage, they already carried poison in their bodies. The poison is usually enough to scare away or kill predators. The ants did not care. They climbed over the toads, bit them from different sides, and kept attacking. The toads stayed still. This is because cane toads depend heavily on poison for defense. Their normal survival trick is simple: stay still. Let the poison work. Against the ants, this strategy failed. The ants kept biting. They kept pulling. They kept attacking until the toads stopped moving. Scientists became interested because this behavior was not normal. Most animals in Australia avoid touching cane toads. These ants were doing the opposite. Meat ants live in large colonies. A single colony can have huge numbers of workers moving around every day. They are aggressive insects and are known for protecting their territory. What surprised researchers was how organized they looked while hunting the toads. One ant would find a toadlet. Soon more ants appeared. Then even more arrived. Within minutes, a group attack started. The ants acted almost like one living machine. Researchers discovered another important detail. The poison from cane toads affects animals with bodies very different from ants. Many larger animals have organs and body systems that react badly to the toxins. Meat ants do not react in the same way. Because of this, the poison defense that works against snakes, lizards, and mammals does not stop them. This gave the ants a huge advantage. Timing also mattered. Baby cane toads are weakest during metamorphosis. This is the stage when they stop being tadpoles and become tiny land animals. During this period, they move slowly. They stay close to water. They sit in open places. Warm weather helps the ants become more active at the same time. This creates the perfect hunting moment. Scientists watch these attacks happen again and again near water edges. The results shocked many people studying invasive species. In some places, researchers estimated that ants killed as many as 98% of the young toads leaving the water. That number is important because cane toads depend on huge numbers of babies surviving. A single female can produce thousands of eggs. If most babies die early, fewer adults appear later. Researchers saw ants dragging baby toads across mud and back toward nests. They saw groups attacking from several directions at once. They saw the same pattern repeat near different ponds. Suddenly, people started asking a new question. What if these ants had been fighting cane toads quietly for years without anyone noticing? For a country that had struggled with this problem for decades, the discovery felt important. The answer was not coming from expensive machines or new chemicals. It was coming from tiny insects already living in the soil. The ants were not trained. They were not changed in laboratories. They were simply using an opportunity nature gave them. How did cane toads become such a massive problem in the first place? And how did a few imported animals grow into millions across an entire continent? Let's delve deeper. How cane toads became one of Australia's biggest problems. Long before people noticed ants fighting young toads, cane toads had already changed large parts of Australia. Their story started many years ago when farmers faced problems in sugarcane farms. Beetles were damaging crops and reducing harvests. People wanted a fast solution. Scientists and farming groups believed bringing in cane toads could solve the problem. In 1935, just over 100 cane toads were brought into Australia. The plan sounded simple. The toads would eat the beetles, the crops would improve, the problem would disappear. That is not what happened. The beetles mostly stayed higher up on sugarcane plants. Cane toads mostly stayed on the ground. The two rarely crossed paths. Instead of eating enough beetles, the toads started eating many other things. They ate insects, they ate small animals, they adapted quickly. Most importantly, they reproduced very fast. Over time, their numbers exploded. Those first few toads turned into millions. Eventually, estimates suggested there were more than 200 million cane toads across large areas. They spread into new regions year after year. Their movement across the country created problems for wildlife that had never seen animals like them before. One reason cane toads became so successful was their poison. Behind their heads are glands that release toxic substances. These poisons protect them from predators. Many Australian animals did not understand the danger. Snakes tried to eat them. Goannas tried to eat them. Crocodiles attacked them. Quolls hunted them. Many died after doing so. In some places, predator populations dropped sharply after cane toads arrived. This created bigger problems. When predators disappeared, ecosystems changed. Smaller animals behaved differently. Other pests increased. Food chains shifted. The effects spread beyond the toads themselves. Cane toads also survive well in different environments. They breed near water. They travel long distances. They can live in hot places and adapt quickly. Their success made controlling them difficult. People tried many solutions. Communities collected toads by hand. Traps were built. Barriers were created. Researchers explored new ideas. None fully stopped the spread. The challenge was simple. There were too many toads over too much land. Because cane toads produce huge numbers of young, even removing many adults often changed little. New generations kept replacing them. This is why researchers became excited when they discovered the weakness during the early life stage. The young toads were not unstoppable. They had limits. They were slow. They gathered near the water. They relied too much on poison. These weaknesses created opportunities for natural predators like meat ants. The cane toad story shows how one decision can change an ecosystem for decades. A species brought in to solve one problem created many more. It affected animals, landscapes, and conservation efforts across large areas. Yet nature also showed something unexpected. Sometimes resistance grows quietly. Sometimes the smallest creatures become the biggest surprise. In this case, tiny ants showed that even one of the world's most successful invasive animals still has weaknesses. If local predators already existed in Australia, why were native frogs surviving these threats while cane toads kept falling into the same deadly traps again and again? Let's find out. Why native frogs survive better than cane toads. Scientists studying cane toads discovered something important. Native frogs and cane toads do not react to danger the same way. Even though both are small animals living around water, one group survives attacks much better. The other struggles badly. Native frogs have spent thousands of years living beside Australia's insects, birds, reptiles, and other hunters. Over time, they learned how to react. Their bodies changed slowly across generations. Their survival skills improved. Cane toads did not grow up in this environment. They came from another place. Because of that, many of their survival tricks do not work very well in Australia. Researchers noticed that local frogs move faster when danger comes close. They jump quickly, they change direction fast, they know when to freeze and when to run. These small actions make a huge difference. Cane toads often do not react the same way. Young cane toads sometimes pause when danger appears. Sometimes they stay still for too long. That delay may only last seconds, but seconds are enough for predators to attack. Scientists wanted proof, so they tested cane toads against several native frog species. They measured how far each animal could jump. They measured speed. They measured endurance. In almost every test, cane toads performed poorly. They jumped shorter distances. They ran slower. They became tired faster. Native frogs consistently performed better. These differences might sound small, but for tiny animals, movement decides survival. If an animal cannot move quickly, predators catch it. Researchers also found that young cane toads make another mistake. They often leave the water during daylight. This behavior probably helps them avoid larger cane toads because adults sometimes eat younger toads. But leaving during the day creates a new danger. Many ants hunt during daylight hours. This means young toads walk directly into areas full of active predators. Native frogs avoid some of this danger because many species become active later in the day or during the night. Timing matters in nature. Being active at the wrong time can become deadly. Scientists describe this situation as an evolutionary trap. This happens when an animal enters an environment where old behaviors no longer work. Cane toads evolved in places where these exact threats were less common. When they arrived in Australia, they faced predators they were never designed to handle. Their instincts stayed the same while the environment changed. This created problems they could not easily solve. Researchers observed young toads during the short period after they changed from tadpoles into tiny land animals. This stage is dangerous. Their muscles are weak. Their bodies are still adjusting. Their skin loses water quickly. Because of this, they stay close to shorelines where moisture remains. Unfortunately, these same areas are where predators gather. The shore becomes a narrow path every young toad must cross. Scientists watched this happen again and again. Native frogs often escaped. Cane toads often struggled. The difference was not strength, it was behavior, it was speed, it was reaction time. Over many years, small differences become huge survival advantages. Could scientists use these weaknesses to their advantage and turn natural predators into a stronger weapon against the invasion? Let's learn more. Using natural predators to slow the invasion. After watching predators attack young cane toads naturally, researchers started exploring ways to help this process happen more often. The goal was not to introduce dangerous new animals. Scientists already knew introducing species into ecosystems can create disasters. Instead, they focused on animals already living there. They wanted to work with nature instead of against it. Researchers noticed that ants were already hunting around shorelines where young cane toads appeared. This gave them an idea. If more ants could gather around these areas during the short period when young toads leave the water, maybe more toads would die before reaching adulthood. Scientists tried something simple. They placed cat food near shoreline areas. The strong smell attracted ants quickly. Within hours, ant activity increased. Areas that were once quiet suddenly became busy hunting zones. Researchers observed what happened next. Young toads leaving the water entered spaces filled with predators. Many were attacked almost immediately. The bait itself was not poisonous. It did not kill toads directly. It simply changed where predators gathered. Scientists liked this method because it was simple and cheap. Instead of building expensive barriers or trying impossible continent-wide removal programs, they focused on small areas where young toads naturally concentrate. But researchers also understood the risks. Ants do not only attack cane toads, they attack many small creatures. If predator numbers increase too much, native species may also be affected. Because of this, scientists focused on very specific conditions. Young cane toads usually appear during the daytime. Many native frogs appear later when ants become less active. This timing difference helps reduce accidental harm. Researchers stressed that this approach must be used carefully. Nature rarely gives perfect solutions. Success also changed, depending on location. Some shorelines worked well, others did not. Soil type mattered. Sandy areas created different results than rocky areas. Plants, sticks, cracks in the ground, and hiding places all changed survival rates. Areas with nearby ant nests usually produced stronger results. Areas without many ants showed weaker effects. This proved that local conditions matter. Scientists repeatedly warned people not to think of ants as magical answers. No single predator will eliminate cane toads. Large invasive populations rarely disappear from one solution alone. Instead, researchers support layered control. This means using pressure at many life stages. Ants attack young toads after they leave water. Other animals eat eggs and tadpoles earlier in life. Combined pressure reduces survival repeatedly. Each stage creates another obstacle. Scientists believe these combined effects matter more than any single strategy. Researchers also used histories as a warning. Many ecological disasters started when humans introduced species hoping for easy solutions. Aggressive predators sometimes become problems themselves. Because of this, scientists prefer supporting natural predators already living in ecosystems. In the end, the lesson from cane toads is simple. Even powerful invaders have weaknesses. The poison protecting cane toads works well against large animals. It works less effectively against tiny attackers. Small predators exploit that weakness. They do not need to overpower adult toads. They only need to reduce the number of young animals surviving each year. Victory in ecology does not always mean removing every invader. Sometimes success means slowing the damage enough for nature to recover little by little. If tiny ants could expose a weakness in one of Australia's most toxic invaders, then another question begins to grow. Could local communities, natural predators, and changing ecosystems finally slow down a problem that has lasted for nearly a century? Stay tuned for more. Community fight back and new questions about the future. As more people learned that meat ants could help reduce baby cane toad numbers, local communities started trying these methods themselves. Farmers, wildlife workers, local groups, and people living near wetlands began putting simple bait near ponds and water areas where cane toads breed. The reason was simple. Cane toads had spread across huge parts of the country, and waiting for large government programs alone was not enough. Many people wanted to protect the animals and places around them. Small actions started happening in farms, parks, wetlands, and even near homes. This turned into a community effort where many people worked together instead of waiting for one solution. People living in areas with large cane toad populations started paying more attention to breeding seasons and watching where young toads came out of the water. The idea was not to remove every cane toad. The goal was to slow them down before their numbers grew again. This local involvement became important because large invasive problems often become too big for scientists or governments to handle alone. When communities joined in, more places could be protected at the same time. As the ant story spread, another thing happened. Rumors and strange theories started spreading too. Some people began asking if the original release of cane toads many years ago was really a mistake. Others wondered why it took so long for scientists to notice ants attacking the young toads. A few people even claimed there were hidden experiments or secret studies connected to the invasion problem. These stories spread quickly because the whole situation sounded unusual. A tiny insect fighting one of the most toxic animals in the country sounded almost impossible. But researchers continued repeating the same message. There is no strong evidence supporting those claims. Studies continue to show that cane toads were introduced for farming reasons and the environmental damage happened afterward. Scientists warned that focusing too much on unsupported stories could distract people from finding practical solutions. While the success of meat ants excited many researchers, scientists also gave an important warning. More ants does not always mean better results. Ants are predators. They do not only attack cane toads, they also hunt many other small animals living in the same environment. If ant numbers become too large in one place, they could put pressure on native insects, frogs, and other species. Nature works through balance. Changing one part too much can create new problems somewhere else. Because of this, researchers argued that helping natural predators should be done carefully. The goal is not to create giant ant armies everywhere. The goal is to support natural systems already working inside the environment. Scientists also notice something interesting happening over time. Both sides of this fight may be changing. Cane toads appear to be adapting as they continue spreading across different parts of the country. At the same time, meat ants living near cane toad breeding areas seem to be getting better at finding places where young toads emerge. Researchers are still studying this because evolution takes time, and many questions remain unanswered. The biggest lesson from all this research is simple. There is probably no single answer that will completely stop cane toads. The invasion became too large many years ago. Removing every toad across huge areas is unrealistic. Instead, scientists now focus on slowing population growth and reducing damage. Meat ants revealed an important weakness in the cane toad life cycle. Young toads may carry poison, but they are still vulnerable when they first leave the water. By attacking them during this stage, natural predators reduce the number surviving into adulthood. This does not remove the problem overnight. It creates pressure over many years. Researchers believe long-term success will come from combining different strategies together. Natural predators, local conservation work, careful monitoring, and community action may all play important roles. What do you think about the idea of tiny ants taking down cane toads? Share your thoughts in the comments section below. Thank you for following this journey into Australia's fight against cane toads. If this story changed how you see invasive species, don't forget to like and subscribe. Click the next video to explore more stories. See you there.